solving a linear system. So we've been looking at linear equations. A linear system is just two or more equations that you're looking at the same time. Two or more linear equations, okay? And when we solve a linear system, the solution, okay, I want you to copy this down. The solution is the point of intersection. So I'm going to call that POI for short form. So if I have two linear equations, as you can see on this graph, if I ask you to solve it and I ask you the solution, the answer is a point of intersection. So who can tell me, where do the lines intersect? Where do they meet? Where's the point that they intersect? Raise your hand if you can tell me the coordinate of the point of the intersection of the two lines. Everyone see it right here? That point is located at, if this is 0, 0, -1, -1, 2. Okay, does everyone see that? That's the answer. That's it. The point of intersection is -1, 2. Okay, so what that means, we read a coordinate x, y. Okay, so this point is common between the two lines. Okay, so that means x and y is a point on line, I'll call this line A, and it's a point on line B, correct? So this point is called the point of, what would be, fill in the blank here? Intersection, good. Okay, and then the second point here, this is also referred to as the blank to the linear system. The what? What is this referred to as? Yes? Solution, good. This is the solution. So if you're asked to solve, you're looking for the point of intersection. In the first example, the lines were graphed for you. So once the lines are graphed, it's easy to figure out the point of intersection, right? Now in this example, we actually have to graph the lines ourselves. So one of the easier ways to graph a line, and we did this last chapter, is to find the x and y intercepts. You guys remember this? You need to know this again for this chapter. So this is equation 1, and this is equation 2. So we're going to start with equation 1. I'll do that one with you, and then you're going to do equation 2 on your own. To find an x-intercept, we set y equal to 0, right? To find the x-intercept. So we're going to graph it by finding the x and y intercepts, and then we'll plot them on the graph. And then we'll connect the points and see where they intersect. Okay, so I'm using equation 1. 3y, well, if I'm making y 0, I have to put 0 here, minus, what does the equation say? 3y minus x equals what? Okay, so what's 3 times 0? 0, take away x equals -3. If negative x is equal to -3, but I want to know what x is equal to, positive x, what do I need to do to both sides? Okay, maybe this will help you. If I put a 1 here, I'm saying that -1x equals -3. How do I isolate x? What do I need to do to both sides of the equation? Yes? We have to undo the operation. This is -1 times x. The opposite is multiplication. If I divide both sides by -1, then the right side I need to divide by -1. So what's -3 divided by -1? Good. Negative and negative make a positive. So x is equal to 3. And if you think about it, if negative x is -3, then positive x equals positive 3, right? Okay, now let's find the y-intercept. To find the y-intercept, we set x equal to 0. So we're going to use the same equation, 3y minus x is 0 equals -3. What's 3y take away 0? Good. 3y equals -3. What do I need to do to both sides to isolate y? Divide both sides by 3. So y is equal to, what's -3 divided by +3? Pia? -1. Good. Okay, so that's the first line that we're going to plot on the graph. I know that my x-intercept is 3, which means I'm going to have a point located at 3, 0, And my y-intercept is -1. So I'll have a point located at 0, -1. So I want you guys to plot those 2 points on the graph right now, below. So x is equal to +3, okay? Already, just by looking at the two equations and the two intercepts, can you make a prediction about where you think they're going to intersect? Okay, so what's the y-intercept? We're going to make x equal to 0. So 2 times 0. And again, we're using the second equation, which is here, equals 6. 2 times 0 is 0. 3y equals 6. Divide both sides by 3. Y is equal to 2. Okay, did everyone get 3 and 2? Yeah. So let's plot line 2 on the graph. Okay, so this is x, and this is our y-axis. Where was the x-intercept again? Okay, x-intercept is located at 3, so I know the first point is going to intercept the x-axis at +3, and what's the y-intercept? -1. Okay, those are the 2 points that are on the line, so now I have to connect the points. Use a ruler and connect the points. So this is line 1. So now we have to do the exact same thing for line 2. So go back and try and find the x and y intercepts for line 2. So for line 2, x is equal to 3, and y was equal to 2, +2. So I'm going to connect the lines, connect the points, and we can even extend this. You should be using a ruler. I can extend both of them. We know it's going to be a straight line. So just by looking at it, and you made the prediction, where is the point of intersection? What's the solution to this equation, to this system of equations? What's the solution? Yep. 3, 0. Good. Right here. 1, 2, 3, 0. If you wrote 0, 3, is that right? No. Where's 0, 3 located? On which axis? X or Y? Y. Good. 0, 3 would be 0, 1, 2, 3. Right here. That's not the point of intersection. It's 3, 0. Okay? Good. So we're going to check, and you might be asked to do this on a test. We're going to substitute, so plug in the x value and the y value. How do I read a coordinate? X, y, or y, x? So this is x, and this is y. So I'm going to plug that into both of the equations to see if it satisfies the equation. What am I checking to see if what happens? We're trying to see that if I plug this into the equation, if my equation will be balanced. I want to know if the left side is going to be equal to the right side. And we've done this a lot. Checking your answer, right? You've done this. Okay, so I have 3 times, what is the answer for y? What's y equal to? 0. Minus, what's x? 3 equals -3. What's 3 times 0? 0 take away 3 equals -3. Is this true? What's 0 take away 3? So -3 equals -3. So yes, this solution works. It's correct for that equation. It satisfies that equation. If I plug in x and y, I balance my equation. So it has to be a point on that graph. What about equation 2? 3 times y. What's y?
0.
Good. Plus 2 times x. What's x? Equals 6. What's 3 times 0?
0.
Plus 2 times 3? What's 0 plus 6? Does it satisfy this equation? Yes. So it works.